Alright, so we're rolling. It's a new video about data displays, and in this video we hope that you will learn about circle graphs, bar graphs, stem and leaf plots, number line plots, and histograms. I'm going to give you a brief overview. Hopefully this is review information for you. First of all, we're going to talk about a circle graph, and circle graphs are also known as pie graphs. So just really quickly, we've got a pie graph of your favorite candy bars. See, it's a way to compare preferences of things, and then that's followed quickly by a bar graph of your favorite pies. So just backing up, pie graph of candy bars, bar graph of pies, and this is a bar graph. A bar graph has got words as what you're measuring typically, colors, pies, some sort of a thing like that. So we don't do a lot of bar graphs in our high school math classes. You'll see them all over the place, but we're more interested in the sort of number type of graphs. Okay, this graph right here is called a number line plot, and it's called a number line plot, well, because first of all we start with a number line, and we're making our plot on there. So what I've got is some data about the number of runs scored by the Red Sox in June 2010, and it works really simply that if you've got the number 9, you take an X, you pop it here on the number 9, and then if you've got a 6, you take the X and you put it where the 6 is, and if you've got more than one of them, like we've got an 8 here and another 8, we stack them on top of each other, and it gives us a general idea as we work through where their strengths were. So in this case, they scored no runs at least once. The most runs they scored was 13. I don't know what that's about, but I don't really want any color change schemes. So it's a number line plot. Typically, what we use a number line plot is when we have a small spread of data. I don't want to make a number line that goes from 0 to 100. If I can probably go from about 20 numbers spread or something like that. And a small amount of data would be another piece. I don't want to make a number line plot with 100. Heck, I don't want to make it with more than like 30 probably. I don't want to keep making X's and make a giant stack. So if I have a small spread, small amount of data, I want to make a quick graphic representation of my data. Number line plots are excellent. The next layer would be a stem and leaf plot. I know you've seen these probably in 6th grade, someplace around there. So we'll quickly review how a stem and leaf plot this side. These are the stems. Typically, they're the first digit or the first couple of digits of our number. And then we have the leaves on the other side. And the leaves represent the kind of last digit. So if I'm looking to put 100, pointer here, if I'm looking to put 100, I grab the 0, I put it right. Doesn't quite work as smooth as I'd like it to, but there you go. So that represents 100. I've got a 54, I grab the 4, and I put it right next to that. Next number is 47, so grab hold of it, and now I've got myself a 47. And then I go down to the 74, and I get 74. And I can just keep going through with all the rest of the data as we go through. In fact, I would suggest maybe that you pause this and just fill in the rest of these numbers as you go on down through, and you get an idea of how that works out. You're just taking the last digit, putting it where it needs to be. Typically, we put the numbers in order from greatest to smallest. So, if it was 99, 98, 97, something like that, we'd work our way through all the rest of those. Pause for a second and finish out that stem and leaf plot, and we'll compare this to the actual one tomorrow. Why is it doing that? Don't show that message again. So, stem and leaf plot, what I notice is I've got a larger spread because I've got scores in this case from, what's the lowest number? Is it 47? 33. I got from 33 to 100. I wouldn't want to make a number line with 33 to 100, and it wouldn't really make much sense because they're all different scores, and maybe 1 or 2 that are the same, but it's not really going to be that great of a thing for a number line plot. And I, in this case, would like to see my A's and my B's and my C's and that sort of thing. So a larger spread is great, and a small amount of data. So again, 20, 30 pieces of data, that's probably okay for this situation, but much more than that, I'm going to want to go to something different. Okay? That's something different, like the histogram. And this really isn't a histogram because it's missing a key feature. But histogram, so what we've done is we've bunched up, and now I've got the points scored by the Celtics in the regular season. So that's like 82 games, so 82 pieces of data. I wouldn't want to make a stem and leaf plot with 82 numbers. I certainly wouldn't want to make a number line plot that goes from 71 to 111. And so what we do is we group the data. So we say, all right, how many times do they score between 71 and 80 points? How many times do they score between 81 and 90 points? How many between, you get the idea. And then we just make the bar that's as tall as that particular number. So I don't know, maybe 27 times they scored between 91 and 100 times. The difference between a histogram and a bar graph is that this is going to come out poorly, in a histogram, the bars actually all touch because we're talking about continuous data, meaning that there's not a whole lot of gap in between the numbers. So between 71 and 80, then 80 to 81. So yeah, we can't do fractional points, but the idea is that we're talking about a continuous piece of data. It's not like we're comparing rhubarb pie to blueberry pie. There's not a whole lot of crossover between them. So in a histogram, we've got let's get an actual pen here that works. We've got a large amount of data. That's probably the key feature. Whatever the spread is doesn't really matter, but I've got a large amount of data. Typically, I'll have more than 40 pieces. If I've got more than 40 pieces or around 40 pieces, I'm probably going to jump to a histogram. The spread really isn't that big of a deal, whether it's a large spread or a small spread. The bars touch. That's the key feature there. Okay? So how do we make a histogram? Just really quickly, first of all, we've got to have some data. Okay? A large amount. That says amount. Large amount of data, doesn't really matter the spread. And again, if we have more than 40 pieces of data, that's probably where I would make that jump. I might say if I have more than 30, but 40 is a pretty good jump. We've got to decide the axes and the scale. So if I'm talking about an axis, this axis is my numbers. This axis is the frequency. So when we're saying frequency, we're talking about how often it happens. Frequency. How often does this occur? And then this axis is the actual data. And it's number data. Okay? So scale-wise, probably we want to pick the intervals so that intervals and scale are sort of the same idea, so that we have probably 10 bars at most. Get any more than 10 bars, and then we're not probably getting good data. So if we're doing, say, grades, things from 0 to 100, it would make sense that our bars count by 10. If we're doing things from 0 to 1,000, it might make sense that our bars count by hundreds, something along those lines. So 10 bars would probably be the piece, and you can experiment with it and see what happens. So let's say we're doing from 0 to 100. So this first bar would represent 0 to 10. And then this might represent 11 through 20. And I would use this, say, initially we did the number of runs scored by the Red Sox in June. If we were to do it over the course of the season, I would certainly want a histogram because there's 162 games. I don't want to make 162 X's. I could easily figure out, and I guess in that case, what's probably going to be maximum is going to be 20. So you might even do, 0, 1, 2, 3, 4, 5, or something along those lines. So once you've got the intervals set up, you collect up your data. So how many times did they get between 0 and 10? And the answer, how many times did they get between 0 and 10? I don't know. Let's say that happens 7 times. Okay, so I'll make my bar for 0 to 10. There, it's nice. You'll use a ruler, make it nicely done. How many times did they get between 11 and 20? That happened this many times. There's my bar for 11 to 20. Okay. So getting the general idea, we make that piece there. So this represents 5. There's 10. We want it to be accurate. 15, that sort of thing. Okay. So finish. We have a title, whatever it happens to be. We label our axes, so number of wins, frequency is always what goes on, and we make a nice, neat job. Okay? So there's a histogram. Moving onward to a circle graph. Circle graph, we have data. We're trying to make some sort of comparison part to whole. Just want to see my time here. Where am I at? Oh, 10 minutes. I'm doing great. Okay. Part to whole. So we're trying to see how does this compare to the whole thing. We take our data, whatever numeric data that we have, and we change it to percents. So let's just say we're talking about, I don't know, what's some good math numbers to use. Let's just go with people that live in Fletcher. I'm going to make up some numbers. Georgia and Fairfax. I'm going to make them easy numbers. Let's say we have 3 from here, we have 5 from there, and we have 12 from Fairfax in our class. Okay? So total is 20. So we need to figure out what percentage. So we're going to change our fraction to a decimal. And then we change our decimal to a percent. So 15% of our folks are from Fletcher, 25% are from Georgia, and that means that 60% are from Fairfax. Okay? So we've got our percentages. Take our data. We're looking at, some sort of picture of where we are, and we change that to a percent. We next need to convert to degrees. Really simply, the way to convert to degrees is we're just going to multiply all of our numbers by 3.6. Okay? I can explain why, but for right now, let's just go with that's what we're going to do. And I don't have those numbers right handy, so hang on for a brief second. All right, so we're back. I just did that quick while we're off camera, so to speak. So 15% represents 54 degrees in my circle. 25% represents 90 degrees in my circle, and 60% represents 216 degrees in my circle. Okay? So then we just are left with the task of, left with the task of adding a page, making a quick circle. Circle, perfect, great. And then I'm going to really fudge this in here, but I know that my 90%, my 90 degrees is going to be there. So that's my Georgia folks. 54 degrees, I'm going to say, is about there. You're going to use a protractor, and we can do a mini lesson on using a protractor at some point when people are actually here and able to use a protractor. And then the rest of it is going to be my Fairfax. So if I was to do this, Fairfax, what was this? This was Fletcher, and these are Georgia. Okay, so I think those are the right numbers. 54% Fletcher. So, and then to finish it up, we'd label it, we'd make it look nice, we'd put some color in it. The computers do a really nice job with that. You pop the data in, it'll make it for you. But we'll practice at least doing a couple of them by hand as we move forward. Okay. Key feature: percents, degrees, multiplied by 3.6. It's a proportional thing, and we can go into why that works as it does. Okay. So, little brief, just comparing and contrasting, particularly those stem and leaf and number line plots and the histograms. So if we go full screen here, okay, so we've got all these little words down here at the bottom talking about how we use these things. So when we talked about having a large spread of data, that's a histogram, correct? Large spread, a histogram. Large set of data, also a histogram. Okay? Small spread, or let's see, a small set of data, that works really well if we have a number line plot or if we have a stem and leaf plot. So we can put that right in the center of those. Okay? So what I would ask you to do is just to fill in, you've got this big chart, fill in the rest of these. So where the rest of these words go, which ones of the various pieces do they represent? Okay? Last little piece, which Girl Scout cookies score the most brownie points. So this is the sort of graph that you see all over the place with the various Girl Scout cookies, 25% Thin Mints, and that's about all we can say about that. So hopefully you picked up on something in here. Hopefully I'm still under 15 minutes. And thanks for watching.